Hi guys, this is Sir Eldon Calamba. So this is another discussion before our sample problem. So let's start. So this time we will be focusing on the vector multiplication. Sorry if I have not corrected the sum of the numbering, but nevertheless it will just be the same. So first off is we have this. I want to discuss this first. We have to discuss the dot product first. Okay, we have two kinds of vector multiplication. We have the cross product and then the dot product. From the videos, from the lecture videos that I have posted, from what I have researched in the YouTube, it just presented two ways in get not two ways. The one way in getting the dot product and the cross product, and that is using your a dot b is just equal to ab cos phi or cos phi, and then the other one that's a cross b that's equal to ab sine phi. But there are instances wherein we have to take advantage of the components of each vectors a and b. So we have the second method, that is the using of components, but still it is a dot product. So by inspection or by looking at your notes, we could always say that a dot b is just equal to ax bx plus ay by plus az bz. This is our second method actually. But how did we come about this one? Always remember that we are multiplying components, right? So we have this identity I.I, J.J, K.K, wherein they always lie on the same line. They are always parallel with each other. So the angle between them, let's say for example, this is just positive I and positive I. So they are in the positive x-axis. And then the angle between them is 0. Hence, if I were to substitute that angle between our two vectors to phi there, we always have 0. And cos 0 will always give you a magnitude of, or it will always give us 1. Okay? And for all we know that these components, this I hat, j hat, k hat, they always have a magnitude of 1. Hence, if we are to substitute AB, that's just magnitude of I, cos the angle between our two vectors I, two unit vectors. So you have 1 times 1 cos 0. It will always give us 1. Hence, if we're going to multiply or do the operations a dot b, so we have here vector A in terms of unit vectors dotted with vector B in terms of unit vectors. So what we're going to do is just do a simple distributive property. So this, what will happen is ax bx or axi hat dot bxi hat, axi hat dot byj hat, and so on and so forth. So we can see this, we could group them to get together, ax bx I dot I plus ay dot bx j hat dot I hat. Okay, and then we have ax bz I hat dot k hat, and we have this identity here, right? So we have here only 1 if we have cos 0, or if they are in the same components parallel with each other. But if we have the opposite one, they are perpendicular, or the other one, not the opposite one, the other one, we have the, if they are perpendicular with each other, I at saka j and k, and I and k, that's perpendicular 90, cos 90 will always give us 0. Hence, we have here I dot j, I dot k. This will always be equal to 0. Same thing with the other one. If we have ay, distribute it there. And then we could say that j dot I, this is 0, and j dot k, this is 0 also. So meaning this will just cancel out. They will just become 0, 0, 0, 0. Same thing with our az. Okay? So hence, if they are all 0, what we're left with is just this I dot I, j dot j, and this k dot k. and that I is just equal to 1 k j dot j 1 k dot k 1. Hence we have this um, uh, in terms of components in solving for the dot product. So you have a dot b is just equal to ax bx plus ay by plus az bz. So that's our one way in getting our dot product. And then the other one is we have here the cross product. Cross product is kind of complicated, okay? Because cross product, as we all know, it is a vector quantity. So we have here ax, this is in terms of magnitude, a cross b, this is ab sine phi. But always remember, cross product is a vector. Hence, we have this n hat here when we don't know the direction yet, okay? But because of these components, we could actually get the directions easily using the I hat, J hat, and the K hat. We have here the simplified version already. That is this one. A cross B is just equal to AY BZ minus AZ BY I hat plus AZ BX minus AX BZ J hat plus AX BY minus AY BX K hat. If you want to memorize this one in getting the the cross product in terms of components, why not if you want? But there's an easy way out for this, and that is using our idea of algebra. We have our matrices. Okay? For this one, we just have to look at this again. AB sine phi. So you have I dot I, J dot J, K dot K. Again, same thing. The angle between these two vectors, I hat and I hat, is just 0. Sine 0 will always give us 0. But if they are perpendicular with each other, as we all know, if we have I and J, J and K and I, it's a different story. There's a summary here, wherein if you will cross I and J, it will result to K hat. That's why if you have a two-dimensional vectors present only in the x and y axis, it's either in the negative k or positive k direction. I'm sorry for the dogs. Okay? And then if you have j and k, it will all j cross k, it will result to I hat, and k hat that I hat will result to j hat. Okay, we also have this one, the opposite direction. I dot j is just equal to the negative j hat cross I hat. So negative j, so going from j hat going to I hat, it will result to k hat. Okay, in the opposite direction. Now, solving for this one, using this idea is kinda it's very long. It's kinda tedious. So I want to take advantage of my understanding of algebra, and that is the understanding of matrices. So this is just a 3 by 3 matrix. You have I hat, J hat, K hat, and that's you have the components already. So 3 by 3, what will happen is that we will be using the basket method if you want. If you want the determinant method, it is also okay. You will always yield the same results. But this one, I will be using the simple one, the basket method. For the basket method, our idea here is just we have to just do down minus up. Okay, what do I mean by that? This is my my own and my my own way, my own method for me not to forget about this one. So you have here your vectors I hat, J hat, K hat, AX, AY, AZ, BX, BY, BZ. You have to arrange them. In order for you to do basket method, you just have to copy this first two columns and then attach it to the end. So you have here 1, 2, 3, 4, 5. 5 columns all in all. So you have I hat, J hat, AX, AY, BX, BY here sa end. Okay? So down minus up. So you want to start from the farthest, from I hat. So you go down. It should be a diagonal. So I hat times AY plus BZ. J hat plus J hat AZ times BX plus K hat AX BY. Okay, this is basically that one. Okay, minus up, up, going up. bxayk hat plus byaz I hat plus bxaxj hat. That is this one. Okay? And then, simplify this one, combine like terms, combine all the I hats, the j hats, and then the k hats. We are left with this one. This is the simplified version. See, just by doing this matrix, we could actually get the component method of cross product. Okay?